To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, we discussed several things related to the solar system and the rotation and the revolution of the planets. Okay. And finally, we discussed what is the reason for that revolution process. So we discussed that the revolution is mainly occurred because of the gravitational force given out by the sun. So like that we discussed several phenomena related to the motion of the planets, and also for the motion of the other celestial objects. So in that case, we identified the main reason behind all of these motions is the gravitational force given out by larger objects. Okay, so we studied those things in our previous chapter, right? Within our previous chapter. So within this chapter, my dear children, we'll be observing some kind of a special phenomena which is going to occur within the Earth. I mean, these things also going to happen for the other planets that has a tilt. But however, as we are living in our Earth, we can experience these phenomena quite well. Okay. So here, my dear children, mainly we are discussing how the seasonal changes are going to occur in our planet Earth. So the occurrence of seasonal changes will be discussing within this lesson part, the seasonal changes. So my dear children, the reason for occurrence of seasonal changes is the behavior or the location of planet Earth when it is going to revolve around the sun. So you know that when the planet Earth is going to revolve around the sun, it is showing a tilt of 23.5 degrees to the rotational orbit. So this tilt is also going to help that uneven distribution of solar energy or sunlight. So because of that uneven distribution of solar energy or sunlight, the seasonal changes occurs. Right? So let's observe and we'll identify and study about the seasonal changes first. How it is going to occur with the tilt and what is this uneven distribution of solar energy or sunlight. Okay, so let's head on with the topic and we'll observe what are these seasonal changes. Right then. Seasonal changes is a phenomenon that occur due to the revolution of the Earth around the sun with a tilt to its orbital plane. So I told you that our Earth has a tilt to the orbit which it is going to revolve around the sun, and because of this tilt and because of the revolution of the planet Earth around the sun, my dear children, we can observe this phenomenon called as the what? The seasonal changes, the occurrence of seasonal changes, right? It's simply like this. When you take some time period within a particular year, right? If that time period has large amount of sunlight, then another time period comes with less amount of sunlight. So during that season with large amount of sunlight, the surface is somewhat dry, and you know that surface of the earth or surface of that particular like the country is somewhat dry. And my dear children, sometimes like leaves are going to fall off due to that extreme heat energy, and it's very difficult to travel, right, and so on. I mean, like, because of the heat energy. So extreme heat is given out, not that much stream, but however a good heat energy is given out by the sun during a certain time period. Then again, in a different time period, my dear children, the amount of heat energy received by a certain surface, by a surface of a certain country, is going to reduce. It's going to reduce. That's mainly because of the revolution of Earth around the sun. When revolving around the sun, during the revolution of our Earth around the sun, my dear children, these things going to change. These phenomena is going to happen. Okay. So, my dear children, when we are discussing about these phenomena, so I told you that in the earlier case, during the dry season, a certain country is going to have, the surface of a certain country is going to have a good amount of heat energy. But however, when the time is going to pass by, the same country is going to receive less amount of heat energy because of this revolution process. So at that time period, my dear children, the energy or the solar power or the solar heat received by the certain surface is going to reduce. That's definitely going to reduce. Okay, that's definitely going to reduce. So we'll be mainly focusing how it is going to occur. What's the reason? Here because of the reduction, right? Here because of the reduction of the heat energy, snow particles are also going to create, my dear children, within the atmosphere, right? You know that our atmosphere contains large amount of water vapor. So that large amount of water vapor is going to condense. It's because of having less amount of heat energy. And those condensed air particles definitely will come and fall, right, as snow particles to the surface. Okay. So the occurrence of snow, here this special season is referred as the winter season. So winter season occurs, right, mainly because of lack of heat energy given out by the sun. So this uneven heat distribution throughout the year is going to occur because of, right, because of this effect. What effect? Because the earth is going to revolve around the sun, but my dear children, with a tilt to its orbital axis, right, with a tilt to its orbital axis. So this is the main reason, right, this is the main reason of having that kind of a effect. So let's see how to explain or what is the process of occurring these seasons and what are those seasons. Okay, right. So my dear children, once again, seasonal changes is a phenomenon that occur due to the revolution of the earth around the sun with a tilt to its orbital plane. When it is winter to England, which is in the northern hemisphere of the earth, it is summer to New Zealand, which is in the southern hemisphere. Alright, when it is winter to the England, now winter means, I told you that's the time period where a certain country receives less amount of sunlight. Because of that, I told you, snow is going to create. Less amount of sunlight is received during the winter season, right? So when winter comes to England, or the United Kingdom, which is located at the northern hemisphere. So there's a specialty, my dear children. Once again, the specialty is that these seasonal changes occurs only to, right? Those things are going to occur only to, right, countries which are located away from the equator, near to poles, right, near to North Pole and South Pole. If the countries are located near to these poles, near to North Pole or to South Pole, right, in that case, my dear children, definitely these seasonal changes can be observed. But however, if the countries are near to the equator, then there is no distinct seasonal changes could be observed. However, the climate is getting changed somewhat, okay, but there is no considerable change within it. Now, if you take England and New Zealand and Australia, right, these kind of countries, my dear children, they face these seasons. I mean, if you take two main seasons, winter and summer, these regions or these countries face these two winter and summer seasons in a good and a observable situation. Like in the winter season, their roads are even getting entirely closed down because of the snow. Sometimes aeroplanes and all the other navigations are being stopped because of the heavy snow, right? So like that way, there are certain cases, right? There are certain special cases. But however, these things can only be observed for the polar region countries which are at the northern and southern hemisphere. I'll be explaining what is the reason for that thing also, right, when I'm going to explain further things within the lesson part. So up to now, you just remember these seasonal changes can only be observed within the countries which are closer to the poles or polar regions, South or North Pole. Okay, seasonal changes cannot be observed, or they will not occur within the countries which are near to the equator. Okay, right then. So when it is winter to the England, when there is snow in England, right, when there is snow in England or United Kingdom, my dear children, which is located at the northern hemisphere, right, then it is summer to the New Zealand. So in New Zealand, my dear children, there is heavy, or the temperature is very high. Okay, so in New Zealand, when the temperature is very high, the temperature is very low in England, in the northern hemisphere. The opposite process also going to work. When there is snow in New Zealand, in United Kingdom, my dear children, there is what? There is heavy, or the temperature is very high or too much high. Summer. Winter and summer are the two opposite seasons. Winter, cold season, summer, the hot season. Okay, right. So these two changes mainly occur because of, right, because of what? Because of the revolution of our earth, my dear children, with a tilt around the sun. Right then. So here it is given, it is known that the earth's axis has a tilt of 23.5 degrees to its orbital. Right, so there is a small bit of a change here, my dear children. Within your textbook, this thing is wrong, right? So it is given as orbital, but it should be orbital. Orbital. Okay, at your textbook the spellings is somewhat wrong, so it should be orbital. Okay, so it is given, it is known that the earth's axis has a tilt of 23.5 degrees to its orbital plane. So to the orbital plane, we know that our Earth has a tilt of 23.5 degrees. Right, 23.5 degrees of a tilt can be observed within the orbital plane. So within these figures you can observe it. So only focus about this area. So now there is a tilt in here. As you can see here, there is a tilt. So this is that tilt. Okay. So this is the vertical axis of our Earth. So this is that tilt, the angle 23.5 degrees. So as you can see here, when it is, now this is the original position, but however it's been tilt like this. Okay, it's been tilt like this. So when it is tilt like this, my dear children, as you can see, the sun rays which are coming is going to hit on the southern surface, right? On the southern surface, like in here, very well. See, up to this extent. See, up to this extent, right? The whole part receives solar energy. This whole part receives solar energy very well because of that tilt. You can see it very clearly within this figure. But however, my dear children, because of the tilt, now you know that this is the part which faces the sun. This is the part which faces the sun. So when sun rays are going to come and hit on the other half of the, when it is going to come and hit the other half, like this, as you can see here. Right now it's going to stop over there. Then what happens for the other countries which are located in this portion? At that portion, my dear children, the countries which are located within this portion, this area, they will receive pretty much less sunlight. Okay, very less amount of sunlight can be observed for the planets which are located over here within this area, right? And also larger extent of the Earth is going to receive sunlight within this portion, and less extent is receiving like this much of a surface only, right? Receiving sunlight from the other portion of the Earth. So as you can see here, due to that tilt, my dear children, right? Due to that tilt, there is an uneven distribution of solar energy through our Earth. Uneven distribution because of that tilt. So that tilt, as the tilt is there like this, right? These areas receive plenty of sunlight, but the top areas receive less amount of sunlight. Less amount of sunlight. Right then. So as you can see here, my dear children, now this area, as it receives good amount of sunlight, here within this area you can observe the summer, and in this area you can observe the winter, right? Summer and winter. Remember, my dear children, these things can only be observed within these two places only, around these two places, around these areas only, right? However, for these places, like this portion, for these portions, my dear children, always the amount of sunlight which is being received is going to take a constant value. Always it is facing the sun. Always it is facing towards the sun. So therefore, for those kinds of places, very less amount of seasonal changes, or there is no distinct changes. There is no distinct changes to be observed. Okay. So this is how the seasonal changes occurs, my dear children. It's mainly because of the tilt shown by the earth and also because of the revolution of the earth. Right? Revolution of the earth. So this tilt and the revolution, my dear children, helps to distribute solar energy uneven to the planet Earth. Okay, uneven to the planet Earth. Right then. So let's head on to observe the other contents. Right. So my dear children, let's see what are the other things given. So revolution of the earth with this tilt is the reason for seasonal changes on the earth. So you can see that the reason for having seasonal changes is the revolution of the earth with a tilt like this. So within the figure you can observe it very clearly. Within the figure you can observe these things very clearly, my dear children, right? Okay. So now let's see what are the other things contained within the lesson part. Consider the position of the earth on 21st June. Here the rays of the sun fall perpendicular to the northern hemisphere. So this is my dear children, the June 21st. So I'll enhance this thing. The June 21st. June 21st. So on June 21st, my dear children, so as you can see here, this is the tilt, this is the rotation, and this angle, this area is not going to receive that much of. So this is the vertical axis. So this area is not going to receive that much of energy, but however, these surfaces, the northern hemisphere, as you can see here, this is the northern hemisphere, it receives plenty of sunlight. It receives plenty of sunlight which is coming. See, sunlight is going to hit directly on these places. See, on these places, right? This is the northern hemisphere, right? And this is the southern hemisphere. You can see the South Africa in here, right? Over there. Then this is the Southern America, South America. So these parts on June 21st receives plenty of sunlight. So this part, which is the northern hemisphere, it receives it has the summer season during 21st of June. And for the same time period, southern hemisphere experience the winter season because, my dear children, less amount of solar energy is getting distributed or being received by the southern hemisphere on June 21st. So it occurs because of this thing, as you can see here very clearly, right? So for these parts, the rays comes, but however for this portion, you can see the distribution of solar rays is very less. Okay, so let's head on to see the explanation once more. So it is given. Consider the position of the earth on 21st June. Here the rays of the sun fall perpendicular to the northern hemisphere. Hence it is summer to the northern hemisphere and the same time rays of the sun falls with an inclination to the southern hemisphere. Therefore, it is cold and it is winter to the southern hemisphere. So as you can see here, my dear children, I'm going to enlarge this thing once again. June 21st, this is the sun. So there's an inclination like this. So these surfaces are going to have large amount of sunlight, while these surfaces are going to have less amount of sunlight, as it is somewhat, if it is facing like this, my dear children, then whole surface will receive same amount of sunlight. But however, because of that tilt like this, these areas receive sunlight at an inclination, right, at an inclination. And these surfaces, as you can see here, when I'm keeping my arm also, you can see that these surfaces are receiving plenty of sunlight which is getting from the sun, right? However, for these areas, sunlight is coming at a certain inclination, my dear children, right? So these areas, within these areas, my dear children, on June 21st, they can experience the summer season as they receive plenty of sunlight. However, for these areas, they receive very less amount of solar radiation or sunlight. So therefore, this winter. So on June 21st, northern hemisphere experienced the summer, while the southern hemisphere observes, or it's going to experience the winter season. Okay, winter season. Then, my dear children, this is what happens in June 21st. So on June 21st, northern hemisphere experience, see, northern hemisphere experience the summer because it receives plenty of sunlight on June 21st, but the southern hemisphere winter. In southern hemisphere winter. Okay, as it receives sunlight but with a inclination, right, with a inclination because of the tilt which is observed within the orbital axis within the orbital plane of the Earth. Right, then the second one. Consider the position of the Earth on 22nd of December. Rays of the sun falls perpendicular to the southern hemisphere and with an inclination to the northern hemisphere. Alright, now let's move on to observe, right? Let's move on to observe December 22nd, which is in here. December 22nd, my dear children. See, December 22nd. Now on December 22nd, as you can see here, now the tilt is not like this, but like this. Because of the tilt, right? Because of the tilt. In the earlier case, it was this. Now it's this. It's like this. So when I keep my arm like this, you can see it very clearly. My finger areas, these areas, it receives sunlight at an inclination, right? Somewhat far away from the sun. So the solar radiation received by my fingers is somewhat less. However, my hand, this area, right? My hand, the bottom area, the base of the hand, it is facing towards the sun very well. And because of the tilt, my bottom area of the hand is somewhat, somewhat closer to the sun rather than these areas. So in that case, my dear children, so this is the north, this is the south. So this area receives more sunlight right? It receives more sunlight, but however, this area receives less sunlight. So because of that uneven distribution, my dear children, this area, which is the southern area or the south pole, it has the summer. It has the summer. While this area, the North Pole, the area of the countries in the North Pole, because of having less sunlight, it will have or it will experience the winter. Okay, it will experience the winter. This is mainly because of happening because of the uneven distribution of light rays because of that tilt. Right? When you zoom it in, the figure, you can observe it very clearly. Right then. So, on December 22nd, my dear children, right, what will happen? The sun rays are going to directly fall on southern hemisphere. So, more sunlight can be observed at the southern hemisphere and summer season can be observed. But however, for the northern countries, for the northern hemisphere, less sunlight is being received. So therefore, because that less sunlight is being received because of the inclination or because of the tilt, right? So at that time period, my dear children, northern hemisphere will experience the winter. Right? It will experience the winter. The opposite process of the previous case. Okay, opposite process of the previous case. Right then, so I'll once again go ahead with the same. Then let's see what are the other contents. So therefore, consider the position of the earth on 22nd. So December 22nd is this. So the rays of the sun falls perpendicular to the southern hemisphere and with an inclination to the northern hemisphere. So we discussed that with an inclination to the northern hemisphere, but however directly facing towards the plenty of sunlight is being received by the southern hemisphere. Therefore, winter occurs in northern hemisphere. So therefore, as you can see here, winter occurs in northern hemisphere and summer to the southern hemisphere. Summer to the southern hemisphere. Seasonal changes are distinct in polar regions. So seasonal changes can be observed, my dear children, especially within the polar region. So I told you that that tilt is going to, right, because of that tilt, my dear children, that tilt is going to give out the seasonal changes, mainly focusing with the, or mainly those, mainly for those areas that has the, that are located within the polar regions. Okay. These seasonal changes are mainly occurring because of the tilt. So tilt is affecting only for the areas that are located within the polar region. Okay, within the polar region. So my dear children, in order to observe distinct changes, the countries should located within the polar region, near to polar regions. If the countries are located within this area, which is near to the center of the earth. Center means actually here the horizontal axis. If it is near to the horizontal axis means the equator. Okay. If you take a cross section of the earth, so the exact half of the cross sectional, right, exact half of the cross section is referred as the equator. So near equator countries like Sri Lanka, India, we can't feel this kind of seasonal changes mainly. There is no distinct seasonal changes in these kind of countries. So here, seasonal changes are distinct in polar regions. Countries like Sri Lanka, which are closer to the equator, have no distinct seasonal changes. So we don't have any distinct seasonal changes because we are located near to the equator. So Sri Lanka is a tropical country. Sri Lanka is a tropical country which is located somewhat near to the equator. So we receive sunlight throughout the year evenly, right? Throughout the year evenly, as we are facing always towards the sun, right? No matter whatever the place, we are always facing towards the sun. Okay, right then. So those are with the, so we studied about the, right, those are with the seasonal changes. Those details are with the seasonal changes, my dear children, right? So remember, the seasonal changes mainly occur because of the tilt and because of the revolution of the earth around the sun. Okay, right then. So my dear children, the next topic is given. The next topic here will be discussing about the occurrence of phases of the moon. Occurrence of phases of the moon. So you know that if you take the moon is also showing different phases according to the position, right? According to the position of the month, according to a certain position, right? It's going to show different kind of a phase. Sometimes the moon is not there at all at the in our space or at the sky. Sometimes the moon is showing a very bright surface, a very bright circular surface. Okay, sometimes a quarter, sometimes like a half of a circular surface. So like that, there are several phases of the moon, right? There are several phases of the moon. So we'll be discussing within this lesson part how these phases of the moon are going to occur. So let's see what are the contents given. Phases of moon occur because of the revolution of moon around the earth. And you know that our moon is going to rotate around the earth, okay, as same as the earth is going to rotate around the sun or revolute around the sun. In the same way, the subplanet moon is also going to revolve around our earth. So that is the reason for having phases of the moon. So half of the moon is always illuminated by the light of the sun, but that half is completely seen from the earth only on a full moon day. Now the next thing is that if you take the moon, one half of the moon is completely lightened by the sun. Okay, I mean, like, it's going to, now specialty here is that when you take the moon, right, when you take the moon like this, always my dear children, this half, the half which is facing towards the sun, is always bright. So we can see only that brighter surface. We can only observe the brighter half of the moon. This other half that half is always hidden from us. We never observe that half of the moon. So this half is called the dark, right? Dark half of the moon. Okay, it's the dark half of the moon. This is the brighter half. Always one surface of the moon is facing towards the sun, and that half is referred as the bright half. Okay, brighter half. So, half of the moon is always illuminated by the light of the sun, but that half is completely seen from the earth only on a full moon day. The part of the illuminated half of the moon seen from the earth changes daily to its position. Thus, we can see various shapes or the phases of the moon. Now, when it is going to revolve around our earth, now you know that there is earth like this. So, when this thing is going to revolve around the earth, right? When this thing is going to revolve around the earth, what will happen, my dear children? You can see several phases of the moon. So that phases are clearly observed throughout the month. Okay, there are several phases, right? The two main phases are referred as the full moon and the new moon. Main phases of the moon. Full moon means entirely we can see the bright surface of the moon. New moon means we can't observe any, right? We can't observe any phase of the moon at a new moon day. Okay, so those are the two main phases that we can observe within the phases of the moon, right? So we'll head on to see those things, my dear children, then. So studying how phases of the moon occurs. Now we are going to study how the phases of moon is going to occur. So to do this thing, there's a small bit of an activity. Now my dear children, when I'm doing this activity, remember I'm doing in some kind of a different way so that you can get a more idea about this thing. Okay, when I'm conducting this activity at my lab, at our laboratory, don't misunderstand with this thing with any other details. Okay, just for your own good or to show you a better view, I'll be doing the experiment in a somewhat different way. Okay, right. So here we'll be needing these materials. First of all, to get light, we'll be needing a bulb or else a torch, right? Or else a torch. Then we'll be needing a regiform ball, fixed to a stick, right? A regiform ball fixed to a stick. So these are the two materials that we need. Okay, we'll be needing a bulb, a lighted bulb, and a regiform ball fixed to a stick. These are the two materials that we need, my dear children, right? It's a really simple activity. Then this is how to conduct this activity. So here, use the electric bulb instead of the sun and the styrofoam ball fixed to a rod instead of moon. This activity is to be done in a dark room. Now, you have to do this in a dark room because while rotating, you should observe that a particular object here, right here. Now, this is you, which is the earth. This is moon. Now you have to observe it. How the phases are going to occur like that, you have to observe it. Okay, you're the one who is earth. So you're the one who is going to observe. So this should be done in a darker room, my dear children. Otherwise, you won't be able to identify the faces. Okay. Holding the styrofoam ball, turn around yourself and observe the illuminated part of the ball as in the figure. So, first of all, I'll be looking at like this. I'll be keeping this styrofoam ball and I'm going to rotate and I'm going to observe the faces. Then I'm going to show you through the camera how it is going to work, my dear children. So it's a different scenario. So you don't think about the scenario, you just observe the faces. That's it. Okay? Okay, remember it. Right then. So my dear children, it's a very simple activity. Let's head on to the lab and we'll conduct this activity and we'll observe the faces of the moon. Right, my dear children, now we are about to discuss or we are about to demonstrate how the phases of the moon are going to create. So you know that moon is going to revolve around the earth, right? Moon is going to revolve around the earth. In simple, we can say that moon is rotating around our earth, right? In simple, we can say that rotating, but however, the correct term is revolution. So upon the revolution of moon around our earth, different phases, right, different like shapes of the moon could be observed. So now I'm about to demonstrate how to observe those phases by using these simpler structures and instruments. So by using different instruments, so I have with me a styrofoam ball. This styrofoam ball is going to represent the moon. This is the one which is going to represent the moon, my dear children. And this bulb over here is going to show the light source, which is our sun. Right? Now what I'm going to do here is now I'm going to keep the moon like this in front of the sun. I'm looking at this surface of the moon. You know that moon is always facing towards us only through a one half, right? The other half is always darker. That's the dark side of the moon. This half, I can't see it. This portion, I can't see it. Always I am facing towards this portion. This is the portion which I could see. But right now, I can't see that portion. Why is that? Because light is not falling towards this surface. It's been completely covered. So I can't see this surface right now. Now I'm going to rotate gradually like this. Now gradually this area is going to visible like this. So when I'm rotating, now I can see a crescent like this. This kind of a crescent can be observed. Right? When I'm rotating like this, then like half of the surface can be observed. So when I'm at this position, I can clearly observe the entire surface because the light which is falling from the sun now completely covers the moon so that I can see it very clearly. At this position, I can observe the full moon. At this position, I can observe the full moon. Entire surface of the moon is now visible for me. So when I am going to rotate once again like this, gradually, right, gradually this thing is going to disappear, right? And once again, when I am coming to this position like this, now once again I can't see the surface, right? So this position is referred as, at this position, as I can't see any crater or any crescent of the moon, this position is the new moon, right? So this is how the phases are going to create. You can do this thing at your home, right? Observe the this half while rotating gradually like this. That's how to observe the crescents created during the revolution of the moon. Now, my dear children, I'm going to show how we can observe, right? How you could observe by using these setups. I'm going to show that how you could observe the crescents or the phases of the moon. But however, remember these things. Always the moon is going to revolve around the earth, right? So you just observe. When I'm going to keep and rotate this thing, you just observe how the phases are going to create within the moon. That's it. Don't confuse this thing with the eclipses thing. Okay? Just for a demonstration only, I'm going to show how the craters are going, how these crescents are going to create, how the phases are going to create. That's it. Okay? Don't go and think about further things related with the eclipses, right? In order to give you a more pleasant idea, more good idea, I'm going to show by rotating this structure around the light bulb. Okay, right. So now let's observe how to observe, or how you could observe this thing by using these instruments within the video itself. Okay, so my dear children, now I'm going to show how the phases would create within this particular thing. But however, this is just to show you how these phases are going to work, right? Don't mess up this thing with the eclipses thing. Actually, now there is earth like this, and around the earth this is going to rotate. Okay, remember that thing. Okay, around the earth this thing is going to rotate. Here you can observe the first quarter. We'll imagine that this is the first phase. So in here the whole moon has got darkened right now. Remember, here this is for the educational purposes only, to observe only with the phases. So this phase is the, right here you can observe. Don't think about the light source in here, right? Just think about the surface which you can observe over here. Okay, so the surface is now entirely dark, right? The surface is entirely dark. That means this is the new moon. Now I am going to rotate it gradually. Observe how you can get the crescents, right? See, now you can clearly visible how the crescents are going to create. So when I am going to turn and come back to this position, this is called as the full moon. Now within full moon you can see that the whole surface is very clear to you, right? Then once again when I am going to rotate, you can see that the surface is gradually getting darker, and once again completely getting darker. This is the new moon again, right? So you can observe the crescents over here. Then the full moon over here. Once again another crescent over here. And again the new moon in here. Right? So this is how the phases are going to work, my dear children. So my dear children, now when I am rotating this thing like this, you could observe the creation of, when I am rotating like this, you can observe the creation of crescents very well. However, there is a small bit of a problem over here. Now, this is also identical in creation of a solar eclipse. So don't miss that thing with the solar eclipse thing. Okay, within this position you just observe this surface. and how it is being darkened, right? So for the camera, there is no possible way to show this thing. That's why I demonstrated like in the previous way, right? So don't get mess up with the solar eclipse thing. Just observe how the crescents are getting created. That's enough, right? I'm showing only the crescents like this. Okay, just observe the crescents like this. So this is the full moon, right? So Earth is there. Remember that Earth is there at this position, right? So this side is the right. Earth is there. Now this is my like my fingers are the ones which are showing you guys, and this side will imagine this side, the finger side are the ones which are showing you guys. So as you guys are here, as the moon is in here, you can clearly observe the entire surface, right? Imagine that you are at the end and it's rotating like this, right? Like this. So the ball is not rotating, passing you guys, and you are at the middle like this, not at the end. Okay. So don't think that much of a detail in here. Just observe the crescents. That's it. Okay. Don't mess up with the solar eclipses thing. Right. Okay then. So my dear children, I think that you got the idea how the crescents are getting created, or how the phases of the moon are getting created when the moon is going to revolve around our Earth. So let's head on to the classroom once again and we'll observe what are the other things contained in our lesson. Right, my dear children. So I have conducted the activity in two different ways. First of all, I have checked the phases, right? Then by using a different location, by using a different scenario, I have shown it to you guys how the phases are going to occur, right? So it's very obvious to us that when doing that activity, we can observe several phases. So here the observation is pretty much simple, my dear children, right? It's way more simple. So you can see that different phases of the moon, right, could be observed when rotating, right? So that was our observation. So I'll mention here the moon, within brackets I'll include the regiform ball, right? So our observation was quite simple. Different phases can be observed So different phases are observed when rotating. Right? So I have to mention here the ball, right? Different phases of the ball are observed, different phases of the ball are observed when rotating. So once again you can write these are identical, or we can say in simple, these are same as. These are same as these are same as the phases. These are same as the phases of our moon. So my dear children, once again, when we are rotating, when we are going to rotate, right, you can see that different phases of the ball are observed. And also, my dear children, there is another speciality. These are same as the phases of our moon. These are same or identical to the phases of the moon, right? Same as the phases of the moon, right? So I have shown you that thing by using two different scenarios. First of all, I did the activity according to the same way, then in somewhat different way, so that you can observe it very clearly, right? Okay, then in a calendar there is only one full moon day for a duration of 1 month, but sometimes, very occasionally, there are 2 full moon days for some months. Figure shows the calendar and the phases of moon during such a month. So you know that, my dear children, there are some instances in which there can be 2 full moons in a certain day, month of a year. But these things come very occasionally. Those things are very rare. Okay? Those occasions are very rare, my dear children. Right? So, within a certain month, normally we experience only one full moon only one full moon day. Okay? We experience only one full moon day within a certain month of a certain year. That's the normal case. But however, occasionally there can be 2 also. So this calendar shows that kind of a month, and these phases represents, right? These phases are going to represent the diagram which is given in here represents the phases regarding each of those days. So here, my dear children, right? Here, my dear children, you can clearly observe how the phases are going to occur in each of these days, right? In each of these days, how the phases are going to observe, right? How does the phases are going to occur? So this is the one which represents the calendar, right? So this is the month, and this is the phases of the moon in each day of the month. So I think it's very clear for you guys when you are looking at the calendar month and the phases, right? Okay, then. So you are given with 2 questions. Answer the questions given below based on the figure above. First question given: what are the phases of moon on 2nd and 31st of this month? So this is 31st and this is on 2nd. As you can see here, my dear children, the entire surface of the moon is being exposed now. We can see a very good circular surface. Okay, and it's been clearly observed for you guys as well. So if it is observed like this, my dear children, I told you that this kind of a phase is called as, if the entire surface of the moon is visible to us like this, then this kind of a phase is referred as a full moon. So we can write the answer: full moon. Full moon. Then the next one, what is the name used for the face of the moon on 16th? Now on 16th, my dear children, I'll use a different color, right? This is on 16th. On 16th, my dear children, you can see the surface is black color. The surface is in black color. We can't observe a clear surface. It's in black color. So the entire surface is in black color means, my dear children, even though the surface is there, even though the moon is there, we can't observe it. Sunlight is not falling well onto that particular surface. So we can't observe it very clearly. So this is referred as the new moon. This is referred as the new moon. So these are the two main phases that we can observe, right, within the phases of the moon, my dear children. Okay, phases of the moon. So I hope that you took a good knowledge about the phases of the moon and how does the seasonal changes are going to occur, right? So this is how the seasonal changes and the phases of the moon is going to occur. So these things mainly occur because of the revolution process, right? Revolution process of the celestial objects. So during the seasonal changes, it's because of the revolution of the earth and the tilt. So the phases of the moon, because of the revolution or the rotational effect that's going to occur within the moon around our planet Earth. So my dear children, these are the phases of the moon, the two main phases, full moon and the new moon, right? Okay then. So by looking at this figure, my dear children, so here it is given, studying the figure given, you will understand clearly how phases of the moon occur. So by looking at this figure, you can get even more idea about the phases of the moon. So as you can see here, always, all the time, my dear children, one half is colored. So that's the half that we can observe. Okay. And when the moon is going to rotate around the earth, as you can see here, several phases are being observed like this. So this surface, within this particular surface, you can see that the entire figure is darkened. However, within this one, you can see that the entire surface is being lighted up, right? Here within this one, you can see that entire figure is being lighted up. So these two areas are the two main phases which are referred as the new moon and the full moon. If we can't observe the moon at all, then it is referred as the new moon. If we can see it entirely in a good circular shape, then it is called the full moon. So these are the phases of our moon, my dear children, right? So I hope that you got a good knowledge about the phases of the moon, right? So within this chapter, we mainly focused about the occurrence of seasonal changes and the phases of the moon. So my dear children, from that, with this lesson part, I'll be winding up this chapter. So we'll be meeting you with the next chapter in order to study about further things related with the lesson. Now in the next chapter, we'll be discussing even more phenomena related to the lesson part. In the next chapter, we'll be discussing about eclipses mainly. Okay, rather new things will be learned, a good and like in the earlier grades also, we have studied few things related to the eclipses, but however within this lesson part we'll be understanding those things in a greater extent. Okay, right then. So until then, it's time to say goodbye, my dear children. I'll hope that you will Once again, refer the next chapter to study about the further things related with the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.